Hi everybody, how's it going? Everybody awake? No. Sort of, kind of? I'm Quentin Tejani. I'm the conference chair for LASCON. Who knows what LASCON is? Good number. So, for those who don't know, LASCON is the Lone Star Application Security Conference, and it is tomorrow and Friday. And so as an adjunct to that, that conference is put on by the local OWASP chapter, and as an adjunct to that, we like to provide training to the community to help spread the word about application security and software security in general. And it's part of the chapter's mission as a nonprofit organization, and as a part of the OWASP nonprofit industry organization. It's part of our mission to do outreach to the community. So that's why we have this great free training. We have awesome instructors like Josh and Dan that are going to be talking to us about this. So thank you all for being here. I'll come back later before lunch to tell you a little bit more about the community. But 2 ways to kind of keep in touch today. We have a Slack chair area. So if you go to slack.lascon.org, you can join. And you can put in an email. I'll send you a link to get started and create your account, and we'll have channels in there. And that's active throughout the year. And again, the conference is tomorrow and Friday, so we still have some tickets left, not a lot, but a few tickets left. So if you're interested in coming to the conference, please do. And with that, I'll introduce our speakers. So Dan is still CTO, I believe, at Denim, if I get the title right. Sorry about that.
They're not reading me yet.
Dan's CTO at the Denim Group, which is a great organization out of San Antonio, and has been a long-standing member of the OWASP community, both in Austin and San Antonio. Josh is the founder of the conference of LASCON, and has been a long-time leader in the OWASP community here in Austin. Has been a chapter leader, and is also, I think, just wrapping up his term. 1 year left? Or? December. 2 months left on the global OWASP board. So he's actually been representing Austin and the global OWASP community as well. So they're awesome instructors, and they're going to be walking through the OWASP Top 10.
Thanks, Vic. Hey everybody, how you guys doing today? Good? Alright. We're going to have some application security fun today. As Vic mentioned, Dan and I have been instructing this as an adjunct to LASCON for, I think this is our 4th time doing this training, something like that. So, and Dan and I, we both work for different companies. We're offering this free to all you guys because we're very passionate about AppSec, we're very passionate about the OWASP mission, and both of us have been involved in OWASP in one way, shape, or form for over a decade. So we're here because we're passionate about application security, and our goal here is that you'll be passionate about it too, hopefully by the end of the class. So we're going to talk today about a bunch of different things. The class is built around the OWASP Top 10, and for those who don't know, the OWASP Top 10 is changing. In theory, it should change every 3 years. That said, I believe the last OWASP Top 10 was 2013. So it's due for a refresh. And the cool thing is they're actually working on it right now. It's under release candidate 2 for the next version of the OWASP Top 10. And so very, very shortly here, we will have to redo the entire presentation. So maybe you guys can join us again next year at LASCON, where we'll cover the OWASP Top 10 in 2018 release. And we'll hopefully cover some new stuff. I know that there's some interesting things that they're looking at putting in there, like APIs and stuff like that. But for now, we're focused on the 2013 version of the OWASP Top 10. So things we're going to do today, we're going to talk about different concepts and tools and things like that that you can use for your application security testing. We're going to focus a lot of the class on basic security principles, things like input validation that are extremely important, critical in fact, to having secure applications. And then we're going to go through the OWASP Top 10 vulnerabilities. Towards the end of the class, if we have time, we'll probably cover some other types of vulnerabilities, things like buffer overflows, denial of service, configuration management, and then we'll potentially cover some security in the SDLC if we have more time at the end. So Benjamin kind of gave us a little bit of an introduction. I'm Josh. I run the security program at National Instruments. I've been at NI for over a decade now. And my job, amongst other things, is to help all of our developers become familiar enough with application security so that they can then go on and write secure code. They can test their applications to make sure they're functioning properly. And if I hand them a list of vulnerabilities in their application, ideally they can go and fix it. In addition to that, I was tasked with doing some risk management things at National Instruments, and that led to me putting some of my AppSec development skills into place, and I actually created a free open source risk management framework called SimpleRisk. And so that's why I'm the creator of the SimpleRisk platform. And then, as Ben mentioned, I'm on the OWASP board of directors. I've been on the OWASP board. This will be the end of year number 4. And I will not be running again. So yeah, it's been a fun time, and we can certainly talk about that experience afterwards.
Hey, I'm Dan Purnell. As Michael said, I'm the CTO at Denver. I'm a developer by background, originally with server-side Java in the late 90s, in the early 2000s with some of the early .NET stuff. But really what I've done for the past 10 to 15 years of my career is work with organizations looking at how the applications that they are developing and deploying impact the security posture of that organization. So my background is as a software developer who's come into the world of security, as opposed to someone who maybe did a lot of network pen testing and is now focused on web and mobile applications. And so again, that kind of shapes the way that I view these issues. I was the original founder of the chapter in San Antonio for OWASP, and I still help run that chapter today. You can find me on Twitter at Daniel Purnell. Or people make me say that.
Nice. All right. So application security. Right. We're going to be talking about application security today. So what is it? In this context, application security is making sure that the custom applications that you guys are writing, the code that you guys are writing, performs as expected under the entire range of possible inputs. So regardless of what data you're setting into the application, you want to make sure that it does everything that we say it's supposed to do and nothing that it shouldn't, right? And when we talk about security and when you're saying your CISSP, one of the things that they talk about is CIA, confidentiality, integrity, and availability. And so these are the things that we focus on as we go through the OWASP Top 10, is how do we maintain the confidentiality of the data in the application? How do we maintain the integrity so that people aren't mucking with the data? And how do we make sure that the data is online and available so that the people who are supposed to be using our application have the ability to do that? There's a direct relationship between security, or application security, and software quality assurance. And some might even argue that application security is kind of a subsection of SQA. The reason being is software quality assurance, you're typically verifying that software does what it's supposed to do. Right? You're looking at it and saying, here's the list of requirements, does the software actually accomplish these requirements? Well, application security is making sure that the software doesn't do what it shouldn't do, right? So they're kind of one and the same. And a lot of times, organizations will use the same processes to track the bugs as they do the security vulnerabilities. And what this means is, in a perfect world, our intended functionality and our actual functionality overlap, right? We have the same set of things that we want it to do that it actually does. How many of you guys live in the perfect world? Right? So in the real world, it looks something like this. We have our actual functionality, and we have our intended functionality. And they mostly overlap, but we do have spaces where they don't, right? And so in the area where we have actual functionality that was not intended, this is unintended and undocumented functionality, aka security bugs, right? Vulnerabilities. And then the other side, well, where they overlap, we have built features. And then on the other side, we have bugs, right? Stuff that's intended that doesn't actually work. So this is how application security fits into the big picture here. We also have some cultural differences here. Traditional information security tends to have a measured culture. We want to determine what's in place, we want to audit the configurations, we want to monitor the operations in operation. And then application development is this build culture, because we start from nothing, and we have to build from the ground up. We want to create something that didn't exist before, and usually this has some sort of deadline, right? Our application has to be done by X date so that the customer can use it or can deliver to the customer, whatever the case may be. Why does application security matter? Business critical apps are internet facing. We have even more data that's behind the firewall that anybody inside or insiders can access. And we have actual data pointing to very serious vulnerabilities being in most of the applications that we use today. In fact, in Sensic 2014 vulnerability report, it said 96% of the applications that were tested had one or more serious security vulnerabilities. So this is still a huge problem. And then we also have this more and more laws and regulations coming into place about how data is stored and made available. So you got HIPAA that covers the health information. You got SOX, which covers publicly traded companies. You've got the California SB 1386, which is all about residents of the state of California and their PII. And then you have PCI, which covers credit card numbers. Now you're getting even more stuff, right? I think it's GDPR that's coming out of Europe right now. So this is becoming a bigger and bigger issue that all of our organizations are going to have to deal with. By the way, for those of you guys who are taking notes, this entire presentation is available online on the OWASP website. I'll see if I can maybe put up like a quick link or something like that later on today. But you guys are more than welcome to grab that. You can use it for developers. And to give you a little bit of background here, my organization, National Instruments, had originally hired Denim Group to come in and help us do some of these trainings. And Denim Group is fantastic at trainings. They've got very qualified people. They do hands-on activities and things like that. After they came in and did that presentation, they left behind the slide deck and whatnot. And over the course of the years, as OWASP updated the OWASP Top 10, I updated the slide deck. And so what we have, what you guys are seeing is basically the hybrid slide deck between the original stuff that Denim Group had worked on and the stuff that I did after the fact to try and get it up to date and use with our developers. There's two different types of vulnerabilities. There's technical vulnerabilities, which are things that usually surface due to insecure programming languages. This is poor input handling, poor input validation. But the good news is that most of these scanner tools that we use are really good at finding these technical vulnerabilities, because it's just a matter of sending some data in and then looking at the data that comes out. The remediation for technical vulnerabilities is usually just change the code. Right? So my developer goes in and says, hey, we've got a cross-site scripting vulnerability here. Let me do some input validation. Let me do some HTML output encoding. Good. Logical vulnerabilities are due to programming logic. And it's usually due to some poor decision that we've made about trust. Some person said, yes, we can trust that data. They didn't do any validation of that data, and now they've got a workflow that's based on that data. And at the end, somebody's buying stuff for free on our website, right? Most scanning tools, because this has to do with logic is a people concept, not a tool concept. And so most scanning tools can't find logical vulnerabilities, which makes these really, really bad vulnerabilities if you have them in your application. These are the kind of vulnerabilities that lead to free laptops being sold on Dell.com, right? The remediation for these types of vulnerabilities, unfortunately, is a lot more complex as well. It requires architecture and design changes because we're talking about the workflow of the application. It's not usually just, hey, let me flip a bit in the code and now it works. So the OWASP Top 10, this is the Top 10 2013. These are the things that we're going to be covering today. And Dan's got to jet off to the airport. He's got an engagement that he has to do tomorrow, I think. And so he's going to cover the morning session for us. He's going to walk us through as much of this as he can. And then we're going to go off to lunch, and then I'll cover the afternoon session. So that's kind of how we're going to work out here. OWASP Top 10 is not a complete list, right? That's 10 vulnerabilities. There's thousands of vulnerabilities that are out there. It's an awareness document. It talks about the things that are the most prevalent risks, the biggest impact risks that are out there. It's a broad consensus about what the most critical flaws are. But if you want a more complete list, go to WASP. They've got huge threat classification. They take all the vulnerabilities, they break them down by each classification of vulnerability, tell you about every single one of them. It's a really good document. OWASP Top 10, it's nowhere to stop. All right, so with this, I'm going to turn it over to Dan. He's going to tell you guys about some of the basic security principles, and then we're going to go into the OWASP Top 10. Cool? Any questions? Yeah?
The other slide you have a class 1 microscopic.
Oh, yeah. So what this is the difference between the OWASP Top 10 2010 and the OWASP Top 10 2013. So what you'll see is as they're constantly adjusting the top 10 and adding new things, taking stuff away, you'll see things kind of move up and down. You'll see new categories like number 9, for example. Some of them they rename, things like that. So the idea is I tried to give a little indication of how things are changing in the OWASP Top 10. But the interesting thing is, as much as they're changing, they're all kind of staying the same, right? When you look at that list, you're like, wow, injection's still number 1. Maybe we should do something about that, right? Things like cross-site scripting. Hey, it's not number 2, it's number 3. At the end of the day, a lot of this is very subjective, right? We're just kind of looking at it, we're like, yeah, I think we're doing a little bit better. I think our scanners are finding more of those, right? But these issues are still issues. And even with the new version of OWASP Top 10, they're going to be bringing in some new things like the use of APIs and things like that. That's because technology is evolving. That doesn't mean that these types of vulnerabilities are really any less prevalent. They're all still very much relevant. They're very much there. Answer your question. Anybody else? Cool. All right. Turn it over to Dan.
And I guess one other quick question, Ethan. How many of y'all are software developers? And that's what you do during the day or night. Very good. or both. That's good. And an interesting point that hopefully I think feeds into what we're trying to do here today. As Josh mentioned, the OWASP Top 10 evolves, but it hasn't evolved. The original version I think came out in 2000. It was a long time ago. And though the list has evolved, it hasn't really fundamentally changed because there's still problems like injection and cross-site scripting in there. And so, on the one side, I think that is justification for a little pessimism, right? We've known about these problems for a long time, and they're still not solved, and they're still significant enough that we haven't, we knock out this list of 10, we've got like the next 10 problems all just moved up because we'd eradicated the first 10. But I think a reason that this list, that a lot of these issues have persisted is that the security community did a great job of talking to the security community as opposed to doing a good job of talking to developers. And so that's, again, feeds into the reason what we're trying to do here today is to get anyone who's interested, but really to hopefully attract developers to things like this. Because at the end of the day, to fix injection flaws or fix cross-site scripting, security can care about that all they want, but it's the software developers that are the ones that have to understand these issues and avoid introducing them in code and fix them in code. So I'm thrilled to have everybody here today, especially thrilled to have developers because I think that it is in creating this dialogue between security and development that we actually can start to make progress. Fantastic. Okay, good. So we're going to talk through a couple of basic security principles. Before we jump into the OWASP Top 10, I want to talk about a couple of basic security principles because these are ways of looking at the world, of looking at the way that you design and implement systems that if, as a developer, if you can adopt some of this mindset, it can help you to avoid introducing issues in the first place. And if you're on the security side, from a testing standpoint, these are things to understand when you look at systems to see if the systems violate these issues. So we're going to talk about least privilege, defense in depth, systems that fail closed versus failing open, and talk about the concept of separation of duties. And so the idea behind least privilege is you want to give a process only the authority it needs to do its job. Right? So let's say that you're setting up, you give a program that needs to log information to a disk. From a security standpoint, what's going to be the best way to configure this process and its ability. So all it needs to be able to do is log. Should it have raw access to the disk, right? Should it be able to go to sectors and override things and do things like that? It's maybe a little bit overboard, right? Or should you constrain that process to having only read or write rights to a specific directory? Or maybe you can get even more aggressive and say, well, let's only give it read and write rights to a single file, to that log file. But if we look and see that we're doing logging, assuming that the file system and the operating system support permissions, what if we only give it append permissions to a file? That would be the preferable option, right? To constrain what this process will do so that it can only do the stuff that it needs to do, right? That goes back to what Josh said about looking at QA versus security. We want to make sure that if something goes wrong, right? If there is a horrible, disgusting, gross security flaw in this program, that something else is going to step in. The operating system is going to step in and say, well, I'll let you write additional stuff to this one file, but I'm not going to let you write to other files, all right? Or I'm not going to let you read from other files or do other things. And so when you look at things like database access, right? How many people have written web-based applications that communicate with a database? All right. How many of you use the root or SA account to access that database? How many people are lying to me right now? Exactly. I had a buddy of mine that I went to school with. I went to Trinity in San Antonio, and a buddy of mine that I went to school with runs a company that does development. So he's got some onshore folks that do a lot of the design user experience work, and then offshore folks that do the development. And he called me a couple of years ago, and he said, "Dan, I've got this problem. We found out that we had a SQL injection vulnerability in this application that we had developed. And I'd heard about security, and I didn't think, I knew about it, it was important, but I actually didn't think it was important because we never did anything about it. But now we've got the SQL injection vulnerability, people have been exploiting it. And I said, okay, well, what have they been doing with it? How is that web application connected to the database? What account are you using? Like, well, it's on SQL Server, it's using the SA account. I'm like, well, I've got bad news, because you can do all kinds of nasty things like run XP command shells, and sort of procedure things like that, but you're going to need to select that box and reinstall wherever you can. And so that's a situation where, because that system was built in such a way where the database connection had not used least privilege, the impact of that vulnerability being identified and exploited was much more serious. And the remediation process or the recovery process that they had to go through was much greater, because they didn't know, well, is the problem, has any loss been constrained to this database, or is it any database on the system? Or I don't know that these people haven't been using shell level access to the server. So that is a great reason why you want to pay attention to things like least privilege. One thing to note, often the finer grained the security mechanism, the closer you're going to be able to get to least privilege, and the more secure your design is going to be. The argument against that, or the challenge that runs in the opposite direction, is that you then start to run into questions of maintenance of those security configurations, right? If you've got very elaborate security configurations for how a system gets deployed, and those are required in order to enforce all these privilege, that's good, but there's a maintenance cost associated with that. But fortunately, what we see now with the move to DevOps with the focus on automation, that puts you in a situation where it is easier or more justifiable to go through the effort to say, well, let's pay attention to this configuration. We're going to store that configuration as code, we're going to version it over time, and it's going to be automatically applied when we create new environments. So I think that that's always been one of the arguments against least privilege is, well, it's just a lot easier if I can access any file and always run as root, do whatever. Now that we start to see better use of automation and these deployment provisioning tools, that makes it easier to take advantage of the security benefits of least privilege. So least privilege and application security, we talked already a little bit about database access. What capabilities does the user's database connection have when they're performing some action? And are there situations, maybe if you have an application where you need to, where you should potentially have multiple different accounts or connections that you're using? And should an application ever create a drop table and grant deny type privileges? And so that's something to take a look at to understand, hey, what database privileges do I really require for the web application. Should the web application ever be changing the schema and so on and so forth. And what privileges have we actually granted to these database users? That's something, especially with given how common SQL injection vulnerabilities are. It may take a lot of work to test all your code and fix all of your SQL injection vulnerabilities, and that is certainly something that you should seriously consider doing. But something that you can potentially do much more quickly is take a look at the database account permissions and say, hey, can we constrain these permissions so that if there is a problem associated with a SQL injection vulnerability that I don't know about yet, that the impact of those problems will be significantly less. Same thing with file access. What files can be read or written by the application server process or the web server process? What are those files used for? And are you able to execute files on the server? And so that's another thing where you don't necessarily, you want your app server or your web server to be able, it needs to be able to read its configuration. It probably should be able to write its configuration. It needs to be able to read the appropriate files in order to have access to the code and the binaries it's going to run. It probably shouldn't be able to write. And again, that's a situation where if you identify, or if you have a situation where there is again, where you've accidentally given arbitrary file access to some sort of vulnerability in the application, you're going to minimize the damage associated with that, with that compromise. Similarly, when you look at the capabilities of users in your application, so less looking, the last two are looking more like configuration or operating system level concerns. When you're designing the way that your users can access parts of your application, maybe you have administrative users, you've got anonymous users, you've got registered users, that's an important thing to look at as well. Looking from an authorization standpoint of what capabilities should these given users have when they are doing things in the system. And that's something that we'll touch on in a number of the OWASP top 10, looking at specific situations where frequently web applications have security problems associated with that access control. And again, thinking least privilege of how do I set up barriers so that a given process or a given facility can only access the stuff that it really needs to do its job. Any questions about least privilege? Excellent. We have a smart group. So defense in depth. Defense in depth is another security mechanism where you don't rely on a single security control. What you would like to have are multiple independent security measures in place. And the reason for this is this provides a much more robust system where if one thing goes wrong, something else can step in and deal with the issue. And again, a specific example of that is looking at least privilege. If you would like for your web application to, you wish you had written all your SQL access correctly, but you have a SQL injection vulnerability, right? If you've relied only on your code to provide security, you're in a bad situation. But if you have applied defense in depth by constraining the database access with least privilege, that provides control that is going to either eliminate or hopefully eliminate, but likely mitigate or soften the impact of a security breach. And so if you fail to employ defense in depth, you end up with a brittle security architecture, right? You have, if one assumption that you made is wrong, the impact of that on the system is potentially very serious. And it also provides a false sense of security. But with defense in depth, that can provide you with some peace of mind that even if you have a problem or if one of your security controls proves to be ineffective, you may prevent the exploitability of vulnerabilities or at least reduce the impact of the results of the vulnerability exploitation. So let's give an example here. If we look at a company that has a firewall that blocks the unauthorized access to their internal network, well, what if that firewall is misconfigured? Or if there's an exploit that allows a valid service, such as a web server, to be subverted? Or let's say the firewall allows people to go out on the web and take their outdated browsers to malicious sites that have malicious code on them, right? So if your entire defense strategy for your organization is based on your firewall, you're probably going to have a bad time because the firewall is going to let through malicious email attachments, the firewall is going to let in and out malicious traffic. The firewall is a potentially important control, but it can't be the only control. But if you look at an organization that has a firewall in place, if you look at an organization that also has files configured, the file permissions configured on servers and workstations and such that they, people only have access to the stuff they're supposed to have access to. If you look at where they have a strong password policy, so it's not easy to guess account passwords. If you look at there are account restrictions in place via some domain policies or something like that. If sensitive data is encrypted at rest, and if they're running malware and virus protection, well, that creates a much more robust and much safer environment because they're not just relying on the firewall. They have other controls in place that can deal with situations where the firewall is misconfigured or whether an attack by design is intended to get through the firewall. And so the impact of flaws in the system are decreased because other security controls can step in and halt attacks in other ways. So defense in depth and application security, and we'll talk about these on individual OWASP top 10 items as well. But it's a question of when do you want to encrypt database data? When do you want to encrypt data at rest? There is potentially a performance impact associated with that. There's a convenience from a search query standpoint impact of that. But that also puts you in a situation where a SQL injection vulnerability doesn't necessarily mean that all of your sensitive data is stolen. Or if a backup tape of your application falls off the back of the UPS truck, that doesn't necessarily mean that all that data is compromised. And so you have to, those are important design decisions to make of how are we going to protect data at rest? What do we want to encrypt? What maybe does not make sense to encrypt? Implementing application-based authentication and authorization mechanisms. Again, we'll talk more specifically about these individuals in the OWASP top 10. But making sure to have proactive controls in place to say, is this user supposed to be able to perform this action in my application on this data? Looking at configuring deployment environments, we talked about that using DevOps, a DevOps approach, as well as a lot of the automation tools that come along with that. How can we configure our deployment environments so that we're using the security controls that are available for the platforms? Same thing with installation guides for IT departments, which hopefully these days is all communicated as like Dockers and public chat scripts and things like that. Any questions about defense in depth? Fantastic. Okay, now let's talk about systems that fail closed versus systems that fail open. So a fail closed system is going to, typically when you're trying to perform operations, or you ask from a security standpoint, should I be able to do this? If you get the answer back that says yes, then you should do it. If you get the answer back that says no, then you shouldn't do it. If an error is thrown, or if you get back an answer that is ambiguous, how does the system respond? And this is a situation where the system is going to do something, right? A decision has been made, even if you haven't explicitly made it. So the system is going to exhibit some behavior. The trick is you want to make sure that you've controlled that behavior. And if you look at a failed closed system, when they run into an error or an ambiguous situation, they're going to not proceed further. The failed open system is going to allow access when they run into those ambiguous situations. And the important thing from a design standpoint is that you are looking for these situations and making an explicit decision. I haven't written a lot of C in a long time, but has everybody here written a little bit of C code today? Did everybody always check the return values and functions to make sure that things were successful, like when you're opening network sockets and things like that, right? I'm sure everyone did. This is one of the smart classes, so everybody here would always do those things, obviously. But those are situations where, hey, I'm assuming that this will work. I'm assuming that the system stays where it's supposed to be, and I'm going to proceed as if. Well, what if that file, if you couldn't get that file handle? What if you couldn't open that socket? What if you couldn't do the thing you were trying to do? How is the system going to respond when it's placed in those ambiguous situations? So this is something where you want to be making these decisions explicitly and handling these. And there's no right answer here. You would typically think that fail-closed behavior would be more secure, right? If the system just doesn't do something, then it's not going to do something wrong, right? If the system gets in an ambiguous situation and it doesn't mail off those customer records, well, good, we've avoided a confidentiality breach, right? So that seems like a good thing. If someone tries to change a record, they get an ambiguous situation and you don't change the record, well, good, you've protected the integrity of that data. But when you think about availability, that is a situation where the appropriate secure thing to do might not be to block access. If you think about the systems that the doctors and nurses use in a lot of healthcare situations, like ER environments, right? The availability of the data, like failing open and saying, I'm not sure if I should do this, but I'm going to give you access to this data because it is more important for me to give you access to this data, because the implication otherwise might be that someone, that we don't learn about someone's drug interactions or something like that, right? And so, it's not, with security, especially when looking at availability, there are trade-offs to be made where one thing may be better or worse than another. And so it's not always saying that blocking access is going to be the right thing to do. The important thing here is that you identify situations where these ambiguous circumstances can come about, and you explicitly design around them. So, fail closed or fail local, what's our best option with nuclear missile launch software, right? Get an ambiguous situation, probably want to go ahead and launch, right? What could go wrong? We'll clean it up later, right? But that's an important thing that has gone into the nuclear response, which is to say, we're going to have multiple folks that are going to be doing this. So, so each individual missile silo, like, hey, if you get in an ambiguous situation, you probably don't launch the missile, and we'll hope that somebody else has got you covered. Fire door lock control software, right? Get in an ambiguous situation, probably want to open the fire doors, right, or allow them to be open. Again, because the implication or the outcome of a wrong decision could potentially impact life. But what about when we get into more ambiguous situations? Credit card authorization routines, right? So if I go to authorize a credit card, I can get back an answer that says, yes, that's been authorized. I can get back a response that says, no, we're rejecting this. But you can also have the system timeout, right? Or come back with some sort of failure code so that we're not able to get that, response. And I'll talk through two different examples. As I said, I did a lot of server-side Java stuff in the mid to late 90s. And I was ran a company that developed e-commerce and software. And there were two different systems that we built that dealt with online, with e-commerce, and dealt with credit card authorization. And we made two different decisions about how to handle fail open and fail close behavior based on the business context of these systems. In the first case, we did a bunch of work for an online, or as a catalog retailer that sold baseball and softball equipment. And then they had a tremendous amount of success with e-commerce, but their original systems, they had a mini computer-based system that managed the inventory and did all the shipping and whatnot. And so we built the web front end for that. And so what we would do when people would make an order is we would try to auth the card. And then, assuming the order was successful, we'd send it on down the line, and it would get, kind of slipstreamed in with all their catalog orders and go through their existing business processes that they had. If we try to auth the card, obviously if we get back a deny, we're going to deny the order. But if we get back an ambiguous answer, if we get back a timeout or some sort of error, should we make the system fail open or fail closed? Open. And why would we, what would be the justification for doing that, or a justification?
I just wouldn't expect nefarious people looking to get off the
Maybe. Anybody else that thoughts?
Well, generally the orders are very small probably, and you have other controls for huge orders. Say if somebody ordered 50,000 units, you can go back and say what? That's an ambiguous clear for you.
Right. And that's an excellent point. And what I would center in on what you just said, and what informed our decision making at least, was there are other controls in place, right? So these, if they got back an ambiguous response, they had the chance to clean that up because they still had to go through the process of, this guy wants 3 bats and this glove and a bag of softballs and whatever else. There was still time to go through and say, well, we got an ambiguous response, let's rerun this off, right? Because before we actually tape up the box and send it off to the UPS guys, before it goes to them, we have plenty of opportunities to try and get a response back. We can try to clean this up later. And so in that case, we made the decision to design to fail open because we had the ability to clean stuff out later and to withhold the physical goods So that in the case of attempted fraud, we could avoid actually losing the good goods and money associated with that. So we also did work with with an organization that was new. It was a startup company, and what they did is they sold calling cards designed to be bought by parents and sent to their kids that were in college. So the kids in college would call home. Right? This is a business that would probably not get a lot of VCs very excited today. At the time, when calling cards were still a thing, and phone conversations were free. This sounds like something my grandma would have bought me, because she, until she died, was convinced that long-distance phone calls were tremendously expensive. But the way this works is you would go in, make your order, and then you could ship it off to the person who would receive it, and it would print out or get you render a thing you could print out, and so you could cut out from your printer a little scrap of paper that had your phone number on it, right? But it was a soft delivery, right? All done via the web. So in this case, what decision do you think that we made about fail open versus fail closed? Somebody said closed. Yeah. Closed.
Well, because again, if you're going back to the concept before, that you had in the baseball situation, you had multiple opportunities to reach at, and then possibly actually fail if you're consistently getting an inconclusive answer. In this case, you have no more opportunities. It's either yes or no right then.
Exactly. And these guys were getting frauded to the ends of the earth, right? And I guess phone cards are super attractive to some people as of 20 years ago, whatever this was. That's a great point, right? So in this case, we found that they had a significant fraud risk, and because it was all soft delivery, they didn't have the ability to go in and clean this stuff up. And so in that case, we made the decision to say, hey, if we don't get an enthusiastic yes back from the credit card people, then we're not going to go forward with this, right? And so I think those are two good examples to see the decision-making process that went into both of these. And I guess the thing that I would communicate to y'all is the important thing is to recognize these situations where a system can be placed in an ambiguous state. And what you want to do from a security standpoint, just from a design standpoint, is you want to make explicit decisions about how to handle these ambiguous states. Because the system, if you don't make an explicit decision, the system's going to do something, right? It's going to fail open, fail close, crash. I mean, the system is going to continue to behave in some way. You just, from a security standpoint, you want to be in there, you want to control that behavior so that the system is doing what you want it to do. And again, you may make decisions. With security, there are always trade-offs, and it's kind of an aside. I remember talking with one of our big clients, and they said, "Hey, we've got this new thing that we're doing, and we want you to come in and do a threat model, but we want your threat model to ignore the risk of fraud." Right? And I said, "Well, that's stupid," but it wasn't stupid, right? Because they made a business decision that said there is so much value in doing this that we are willing to accept fraud and try to minimize it on the back end. Right, so we want to know the other security risk associated with this, but we've already evaluated the fraud concerns, and that's on us. Right. So again, from a security standpoint, there aren't necessarily doctrinaire answers. There are decisions to be made, but it's important that those decisions be made explicitly. Again, the risk associated with fail closed and fail open, often fail closed versus fail open behavior is not specifically addressed. Right, so there's no specification for how to address it. There's no testing. There's code that may not have been exercised that is going to potentially be exercised in production because you get into these situations. And this leads to situations where you can open up vulnerabilities. You can cause information leakage. And the challenge is that in a lot of cases, the clients, the business owners maybe haven't thought through these scenarios. And these also haven't been addressed in the design documents because the developers assume, well, that's easy, or I don't need to check the return value, or why would this ever fail? So in application security, again, you want to flesh out these requirements. This needs to be an explicit discussion. Implementing error handling routines so that you know when the system is put into an ambiguous state. Looking at how your error code are being handled. That's one of the things that static analysis tools are really good at, is at identifying situations where you have things like, empty catch blocks where you're like, okay, well, hey, catch the compiler's making me catch the exception, right? But I'm just going to put empty brackets after that, right? Has anyone ever done that? Yeah, me either. And again, by knowing about these potential error conditions, this can, you can start to create automated tests around these errors. Any questions about fail open versus fail closed behaviors? Yes?
I think I have a suggestion that, those systems have to have either phase closed or phase open. I'm just thinking about the example that you gave. What if the software company allowed phase open for purchases under some dollar, and maybe phase closed for purchases above some dollar?
Exactly. That's a great idea. So just to repeat this, so everybody can hear it, the question was, what about for the baseball and softball example? What about saying for orders under $100 we'll fail open, but for orders over that we're going to fail close? That's a great example of looking and saying we're going to make a risk-based decision. Like I would rather we know that the credit card processor sometimes doesn't give us a response. I don't want to aggravate our customers that are excited about buying stuff, but for customers that are making a suspicious order, let's, maybe then the balance tips to say, no, we do want to provide more scrutiny to this, even at the risk of aggravating a customer or asking them to rerun the transaction. That's a great point. That's the kind of thinking I think that needs to go into the design of systems to make a determination and an explicit decision to say, I'm willing to accept this risk because I get this business value out of the system behaving in this way. Or I am not willing to accept this risk because there's simply not enough value on the other side of it. That thought process is something that I think is really valuable to foster and nurture in your organization. Excellent. Any other questions? Phil close. Fantastic. Separation of duties. So this is something as a key fraud control measure, and that's essentially look to say. If you look, it's easy for one person to be dishonest. Maybe not easy, right? But it is possible for one person to be dishonest. It is still possible, but less likely that two people are going to collude together to be dishonest. And so when you're designing systems, you want to have a separation of duties so that in order for fraud to take place, one person isn't solely capable of committing fraud. They have to collude with someone else in order to do that. So the person that orders laptops should probably not be the person who confirmed that laptops showed up. Otherwise, that person may also be the individual who sells laptops on eBay, right? And so you want to separate those duties to say, well, hey, this person is doing the purchasing, someone else is confirming that what arrived is what we expected to arrive. And so you want multiple authorities to potentially sign off on high-value transactions. It's also one of the reasons why it's a really bad idea to have normal users run with administrative access, because then that lets them do anything they want to do. I saw something on Twitter a while back that a little quip that says, if you're going to be good at one thing, be good at lying, because then you're good at everything. Right? So you don't want to create those situations where one person has the ability to do to end-to-end run transactions and potentially be responsible for fraud behavior. Yeah.
Should I not have administrative access to my own apps?
That's a great question. The question is, should you not have administrative access to your apps? What we see in most larger environments is a separation between this goes against the DevOps principle, but where the developers have very limited access to the production systems, right? Where they provide something and then that is deployed by someone else, and where the developers don't have access, except under controlled conditions, they don't have access to things like production data. There's another process in place to generate the keys that are used for encryption and things like that in development are not the ones that are used in production. So that's from a separation of duty standpoint, that is appropriate in a lot of situations. That doesn't necessarily mean you can't do DevOps, because you have automation of these processes and ownership, but from a fraud control standpoint, you probably don't want developers to have direct, unrestricted access to production systems. Great question. Yeah, no, that's a great thing that we see again in larger enterprises, in heavily regulated organizations. That's the kind of the application of separation of duties that we see. So any questions about separation of duties? Fantastic. Okay, good. Well, we will jump into the OWASP Top 10 2013 edition. So the first risk or vulnerability that we're going to look at are injection vulnerabilities. And one of the kind of prime examples of injection vulnerabilities are SQL injection vulnerabilities. And so what you find is if an attacker has the ability to run their own queries on your database, it's not really your database anymore. It's kind of their database, or at least it's shared. It's all of y'all's database at that point. So injection flaws occur when untrusted data is sent to an interpreter as part of a command or a query. And so if you think of a web application, let's first talk a little bit about what untrusted data is. So in a web application environment, untrusted data is basically anything in the HTTP request, right? And I don't know if we'll have time to get into specific examples, but basically anything in an HTTP request, you have to assume is under the control of the attacker. So the URL that they're accessing, the parameters that they pass in, post parameters, get parameters, cookies, other headers, you have to assume that all of that is untrusted data, because at the end of the day, there's not a sacred relationship between a browser and a web server, right? What shows up at the web server is just traffic coming over an HTTP or an HTTPS connection, right? You assume that it was created by a browser and that JavaScript ran on the client side and so on and so forth, right? You make that assumption, but you shouldn't, because again, it's just traffic coming over the wire. That's something where we can go in with a web proxy like OWASP Zap, capture requests once they've left the browser and modify them before they show up. Did anybody ever do the trick? I learned this. This is one of two security things I learned in college. Anybody ever do the trick where you telnet port 25 and talk? You type SMTP directly over the wire, so you fake like you're emailing, like you're one of your professors, right? So the SMTP server is assuming hey, I'm getting a connection from a mail client that speaks SMTP. What the mail server didn't know is this is some junior board from board during system administration class. It's telnet to communicate, right? So that's an important thing to understand. So when you're looking at get parameters, post parameters, cookies, those all have to be considered untrusted data. And so when you see this untrusted data coming into the system, is that going to be taken and handed over to some sort of an interpreter, such as a SQL interpreter, such as an LDAP interpreter that's going to run a query? Because if an attacker sends in hostile data, they can potentially trick the interpreter into running unintended commands or accessing data without proper authorization controls being put in place. Right. And so there's a lot of different variations of these injection type vulnerabilities. The most common that gets the most airtime and is probably the most frequently identified is SQL injection. Because most web applications that I've ever worked on is basically a relational database with some code that sits on top of that and takes user input and turns that into SQL queries so that you can show data tables on the screen. So SQL injection is very common. But you can also have situations with operating system. If you ever, from a web application, you ever shelled out to the operating system to do something, that happens less these days. It happened more, back. I remember one of the first e-commerce sites I built was used a Perl script called shop.pl. And what shop.pl would do when it wanted to send an email is it would fork a process and pipe a bunch of data to send mail. And its database was actually the file system. It didn't use a relational database. And so there were a lot of situations where we were executing operating system commands, right? But if I'm taking user input and appending that to some kind of a string that gets sent out to the operating system to run, then you can run into problems like OS command injection. Similar with LDAP, making queries of an LDAP database and not paying attention to special characters. So the impact is potentially severe. If you look at, especially SQL injection, you can have data loss, data corruption, lack of accountability because you don't know who was able to change data, or you can have availability issues, denial of access. And sometimes injection can lead to a complete host takeover. So in that example we talked about earlier, where we had a SQL injection vulnerability in an application that was talking to a SQL Server database using the SA account. Right? So essentially you could run operating system commands with the same level of permissions as whatever local system accounter was running that SQL Server process. And so you need to consider the value of the data that your system is talking to, because that is the potential impact. With these injection vulnerabilities, all data can be stolen, modified, or deleted. There's a really cool tool called SQL Map, and what it will do is if you point it at a SQL injection vulnerability, it will use SQL injection to pull back first metadata about the database, right? To say, assuming that the account accessing the database has sufficient permissions, it'll figure out like what is the table structure, and then it will start to pull back data, right? And so, given an appropriate toehold, a tool like SQL Map can basically say, I'm going to take a copy of your database over there, I'm going to make a copy, I'm going to use HTTP to copy all of the data in that database over to here. So how does this happen? This happens anytime an application is accessing an interpreter. So if you're, again, talking SQL databases, if you're making queries with LDAP, if you're making XPath queries of XML documents, XSLT transforms, if you're making HTML, XML, feeding those to interpreters or in an operating system. So we're going to focus on SQL injection, it's the most common. And so let's look at this code here, where we're going to run, we want to, let's say this is probably the world's worst login routine, right? You've got a table somewhere that has a username, password, or a username column and a password column. You've got .NET controls that username, text control, password, text control. And so what do I want to do? Well, I want to pull, if somebody gives me a username and password, I want to see if those match a username and password in the database. Well, how am I going to do that? Select star from user, so I'm going to grab all the columns, not the most efficient, but sure. Where the username equals whatever the user passed in as the username, and the password equals whatever the user passed in the password. Right? The expectation is that the inputs that got passed in are going to be a valid username and a password. The assumption is that they're also not going to contain any SQL control characters. But what if we pass in a username of apostrophe, right, and a blank password? Or we pass in an input of like apostrophe or 1 equals 1. So if we pass in apostrophe or 1 equals 1, what's the SQL query that is ultimately going to be executed? All right, select star from user, all the columns, great. Where username equals single quote, right? We got the single quote there. Then we've got the single quote that was passed in as the username, plus the or 1 equals 1 dash dash, that was part of the username. And then we see that quote right there, that is from there. And then we see the password equals, the password is blank, right? And so the SQL query that was created, if we just took the username and password, appended those all together, what we get here is a query that is structured very different than what we had before. And if you think of the SQL interpreter, you can hand this over to SQL Server, and it's going to, the interpreter is just, it's like Pac-Man, right? It's got letters in front of it, just like each letters, and that affects the state machine, where it's going to say, okay, sure, I want to select, it's a select query, select star, I'm going to get all the columns from the user table, okay? That's where I'm going to run my query against, where it says username equals blank, okay? That's my first condition, is username equals blank, or 1 equals 1. Well, there's hopefully not any users in the table with the username of blank, because that'd be a stupid username. Or maybe that's like the best username to get, like when Gmail came out, and everybody's like trying to get their name at Gmail and stuff, like blank would be the hardest first one to go. Right? So there's probably not any usernames that are blank. So that's not going to match any rows. But what rows are going to be matched by that part of the conditional? All of them, because 1 is always 1, right? And we're supposed to be checking the password, but what we've done here is something clever, because we put 2 dashes in there. What's that going to tell the SQL interpreter? The common crap. Ignore everything after this, right? And so we have the attacker's been able to fundamentally change the structure of the query, and as such, they've been able to break the design of this login routine. And again, I would argue this login routine is not a very good one, because what it's telling us, what is this telling us about how this login system is built? Yeah. the password is in plain text, right? So that's a red flag, certainly. But again, the design here was, hey, let's see if they match both the username and the password. If they give me a row back, then that is a successful login. If they don't give me a row back, then either the username or password was wrong. But what we've been able to do here, by sending in these SQL control characters that weren't anticipated, is break the structure of the query to say, give me back all of the rows in the user table. And again, when we look at checking conditions, unexpected situations, the design for this is probably planned for if I get one row back, it's a successful login for this user. If I get no rows back, then it's an unsuccessful login. Well, here we're going to get all the rows back, which probably means it's going to step into the first row, log them into the first user, and go on about your business.
Or crash.
Or crash, right? Potentially. If you're lucky, you'll crash. Again, like if you think of the way that a lot of code gets written, it's I got a result set back. Can I step into the first one? Yes. Okay. Cool. Let's keep moving forward. And that's the problem. This is a very natural way. I'm not a database guy, but this is a very natural way to write SQL, right? You're like, okay, hey, what do I want? I want to see if there's a username and password, if a row that matches username and password. Cool. Select. I'm kind of lazy, so I'm going to select star, because who knows what other stuff I might want to use. From, you got to, in SQL Server, you got to put bracket around user, where username equals, it's like the single quote, double quote, plus, plus, double quote, single quote, like those, that's so natural to me from like writing that code so many times that I can like feel myself hitting the keyboard in that sequence of like, double quote, single quote, right? That's a natural way for a coder to write database access. And unfortunately, because it's a natural, that's probably why this is so prevalent. Very common, very damaging. And as we talked about before, many web applications have a high level of permission on on their databases. And so there's a couple, like what can we do with a SQL injection vulnerability, right? We can short circuit the query. That's what we did before, right? There was a constraint that was supposed to be in place for short circuiting that by taking control of the structure of that query and adding or 1 equals 1. So that we get everything back. Or you could add or 1 equals 0 and get nothing, and force it to get nothing back. You can also potentially grab data from other places where you could say, hey, I've got one select query, but I want to union that with another select query, right? And so if I'm pulling back data and it's going to get stuffed in a table, but I have the SQL injection vulnerability, I can pull data back from the intended table, but I can also append the results of other queries to that data table. That's a big part of how that SQL map tool works, to go and grab additional data, from these, once it finds the SQL injection vulnerability, right? You can also say, select star, whatever, semicolon, delete from table, drop table, all right? And again, it really is up to the imagination of the attacker and the constraints placed on it by the way that the code sets up the SQL query, but also how the database is configured. So you see default configuration with things like MySQL where they won't let you run by default more than one query. If it gets to a semicolon and you start another SQL query, from a JDBC call, it will say like, oh no, this is like unless you specifically configured me to allow multiple statements to be run, we won't allow for that. And so this is where that defense in depth comes in, where you can have other controls in place to help mitigate the risk. Obviously, the best defense is not to have SQL injection vulnerabilities in the first place. So again, what we're seeing here is you've got an attacker. They're sending a payload into the application. They pass that payload on by appending it in with other strings to the database, and that is where the attack is executed in this case. This is a great cartoon. Or at least I think it's great. So, XKCD, everyone? Yeah, read it. So, another example here. Right? Yeah. For all the privacy advocates out there who don't like the license plate readers and things of that nature. Right? And again, those are situations where the assumption is that, if you got a database reader, like the hard problem you're trying to solve is to figure out how, like on a car moving 75 miles an hour, like, look, I was able to take a picture of the license plate, and I fed it to some sort of like, neural net thing, and I turned a picture of a license plate into the letters and numbers of the license plate. Like, that's cool. That's the machine learning AI cool stuff. Like, that's the neat part. The bad news is that you were so happy to get like the three character license plate that you never thought like, oh, what if this pulls in more data than it was supposed to, right? So it's when you run across those assumptions that are being made, hey, this input is coming in, we've got to know this input is untrusted. Like whatever is coming out of your weird machine language routine to treat license plates, you probably want to treat that as untrusted. Validate that and make sure that you're properly sanitizing them before, or sanitizing them before you get passed on to some other system. Operating system command injection, same type of situation where you build up an operating shell or operating system shell command from static and unfiltered user inputs. Right, so if I want to do ls-al for a directory name, again, this is something that I saw a lot more in older systems. Like now, if you want to send an email, there's an SMTP library for whatever programming language you're using, right? You don't have to open a pipe to send mail. All right. If you want to access data, you're probably not using directory structures and file structures on your server to do this. It's probably in a relational database, or if you're building an app that's really cool, it's in a NoSQL database, right? And so, there's not as much of a reason to shell out operating system commands anymore, unless you're in some kind of specialized circumstances, but it's potentially really devastating because that allows the attacker to run commands on your web server as if it were the web server user, or on the application server as if it was the application server user. Similar with if you're building up LDAP query strings by appending strings together, you may, if you're not expecting and filtering out special characters like star, again, the structure of that query may change, and so what gets returned from that LDAP query is going to look very different from what you expected to see originally. Okay, so how do you test an application for injection flaws? The good news, bad news here is that it is often pretty easy in a lot of cases. It's easy to test applications for injection type flaws because they tend to have a very distinctive request and response pattern. So if we go back a little bit here, like a way to test, so if I want to test, if I've got an application that's running that stuff, and I want to test it, I don't necessarily need to pass in or 1 equals 1, right? Get that right on the first try. I can simply pass in a single quote, right? What's the database query going to be if I send in a single quote? Select star from user, where username equals apostrophe, 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 and password equals apostrophe, apostrophe, right? Well, that extra apostrophe after the username is going to cause the interpreter to throw an error, right? Because it's going to say, hey, I'm Pac-Man, I'm chewing through these things. Username equals quote, quote, okay, well, it's a blank username. Third quote, well, I'm not supposed to see a quote here. I don't know what to do with this quote here, therefore I'm going to throw an error, right? And so if we want to test applications for SQL injection vulnerabilities, I'm going to pass in SQL control characters, a single quote, a double quote, and I'm going to see what I get back. If I pass in a single quote and I get back a JDBC error message, that's a pretty good indication to me that this application is not handling those single quotes right, and it's not properly escaping those before they send them to the database. Right? Or similarly, single quotes, double quotes, other SQL control characters. That request and response pattern is going to tell me there's something wrong, and that is suspicious enough that I'm going to flag that as a SQL injection vulnerability. So again, you send in SQL control characters, single quote, double quote, semicolon, dash, and look for SQL-related exceptions in your error messages that come back. This is also something, so that's like a dynamic testing way to find it. This is also something in a lot of cases that static analysis tools are easy to find. You have static analysis tools like a Fortifier or checkmarks that do data flow analysis, where it takes the application and looks at like how variables get assigned and whatnot. That's also something that's easy to find with automation of looking at source or binaries. So how do we craft SQL injection payloads? Again, there's kind of two main flavors of SQL injection, or two situations. If you've got a situation where like your input is supposed to be an integer, here we've got like document ID equals whatever integer was passed in, and there's no quotes to deal with. In other situations, you may have to deal with existing SQL, so select star from user where username equals. Again, you've got that single quote on either side of it. You've got to deal with the single quote. So as we did before, we said single quote, that's going to make the username blank, and then we went on to send in the condition that we wanted to change, or 1 equals 1, and then we had clean up at the end by having that dash dash, that comment in there. And the question is, what do you want to do with the payload? Do you want to modify an existing statement, change the results of a where clause, select additional data via union clause? Do you want to end the current statement and write another, semicolon to end, dash dash for comment? Then you can add additional stuff on top of that. And so again, the impact here is really only limited by the imagination of the attacker, the constraints of any input validation that's in place, and any restrictions put in place by your JDBC, your OWBC connection, and the database. Okay, so that's scary. Is everybody scared? It's good. It's almost Halloween. It's okay to be scared. How do you mitigate these? So one thing that is always good advice, but is not good enough advice, is always good advice to positively validate inputs. And that's something where a couple steps down, we've got some discussions about that. But so we're going to positively validate inputs. And what do I mean by positively validate inputs? Positively validating inputs basically says, I'm going to tell you what I want to see. Negative validation says, I'm going to tell you what I don't want to see. So a negative validation that would have guarded against the SQL injection attack that we had before was to say, if username or password equals apostrophe or 1 equals 1 dash dash, then why, right? And in that specific case, that would have worked. That wouldn't have worked against apostrophe or 2 equals 2, right, unfortunately. And so negative validation, although it is not without value, it's a much more brittle strategy for input validation. Instead, for positive input validation, what I want to say is, how long should this input be? Right? If a username is supposed to be 8 to 12 characters, well, let's make sure whatever was passed in is between 8 and 12 characters. Otherwise, I know it's not a username. Also type. Is a document ID supposed to be an integer? Well, let's check and make sure we got a valid integer. The syntax. Hey, if it's supposed to be an email address, let's make sure it actually looks like an email address. And then business rules, right? If it's a price, for example, prices should probably be above 0, for example. They shouldn't be negative, right? And so what are the business rules associated with this input? So for your given input, you want to know what is it that I expect to see, and let's explicitly make sure that we're only getting inputs, or that we're only passing inputs that obey those things. And so if I get an input for a username that's like 1,024 characters, that's probably not a valid username, all right? If I'm supposed to get an integer, and instead I get 32 characters of strings with like exclamation points and wingdings and other stuff like that, that's probably not a valid input. If I'm supposed to get an email address and that has weird control characters other than things you would expect, like an underscore or dots and ampersands, right? And same thing with business rules. If I'm supposed to get a price and I get something that's negative, that's a suspicious circumstance. And so input validation is great because that cleans up the junk that is coming into your application. The problem is that input validation alone doesn't actually solve the problem. Input validation can help make problems less exploitable, but it doesn't solve the problem. What you really need to do to solve injection problems, and other things that we'll talk about, is you need to make sure that these inputs get treated as data to be operated on, not code to be executed. And that was the breakdown that we had with the way that we built that SQL statement before. Because we said, we're getting this data from the user, but we're just appending that to code that's going to be operated on. And because they included characters that we didn't anticipate, that allowed the attacker to hijack that state machine, hijack that parser that was running through and figuring out, given this string, what SQL stuff do I want to do on the other end of that. And so in a SQL environment, what you want to do is look at using things like stored procedures or prepared statements, where you can force you can basically enforce the structure of the query that you want to see. Similarly, you can be helped in this with things like hibernate or unhibernate. You can still have injection flaws with object relational mapping tools. Because again, the queries that you send in are strings, and so if you take set strings plus strings passed in by users and you don't enforce the structure, like they're still going to be able to potentially misuse those. And so we'll look at some code examples of how this works in just a second. You also want to not allow users to see verbose error messages. It said that defense in depth, security through obscurity is not typically a winning strategy, but it is a valuable tool in the toolkit of making attackers' lives harder, right? So as I talked about, an easy way to look for SQL injection is send in a control character, look for JDBC error messages. If you're properly catching that SQL, that JDBC exception and saying, well, hey, I'm just going to show a normal screen, I'm going to send back a 200 that says, sorry, there was a problem, that's going to make it harder for the attacker to figure out a valid payload, versus if you dump like the full stack trace in the exception message where it says, hey, I found an extra apostrophe. Oh, you found an extra apostrophe? Cool. The apostrophe character is what confused it. Now I know, now I can start to visualize as the attacker. I can start to visualize what the code looks like on the server, and I can start to make educated guesses about that. And that error message is going to make it a lot easier for me to find payloads that are going to be effective. So you don't want to allow users to see verbose error messages. And finally, practice defense in depth, restricting account permissions. We talked about this over and over again. So, but the thing here that actually fixes this problem is making sure the inputs get treated as data. And that an attacker can't send in, no matter what they send in, if they send in a username that has apostrophes in it, then the query goes to the database and says, hey, you have users with apostrophes in it. We'll look at some code examples for this in just a second. But this helps, this helps, this helps, this actually solves the problem, right? And so that's something, again, people talk about input validation and that being a very important thing, and it is a very important thing. But I think one important and one critical thing to take away is to understand that input validation doesn't solve the problem. This solves the problem. Input validation takes the edge off or mitigates the risk associated with the with having that vulnerability in the first place. So in a Java environment, we can look at prepared statements. So let's look at this prepared statement here. We're going to update coffees, set sales equal to question where coffee name like something, right? And then we go and we set, hey, I want to set the sales to 75, where the coffee name is like Colombian, and then I execute that update. So how is this different than the code we looked at before? Here, we're defining the structure of the query right here, and we're telling the database connection, prepare this statement. I'm going to run a query where I'm going to update the coffees table. I'm going to set the sales to something that I'm going to give you, but I only want to do that where the coffee name is like something else, and I'm going to give that to you. So I'm calling here then, I want to set my first parameter to 75. It's nice that they don't zero index these. Thanks. Whatever. But I'm going to set my first parameter to an int, and it's going to be set the value of 75. And I'm going to set the second one to the string of Colombian, and that's going to get fed in right there. What that does is that says, hey, JDBC driver, it's your responsibility to properly escape this, right? You can put apostrophes in database tables, right? It's not like SQL Server won't let you put apostrophes in tables. But if you're writing SQL queries, you've got to escape that value, right? So instead of that going in as an apostrophe, maybe it's a double apostrophe, it's a backslash apostrophe, depending on the database server how they do the escaping. What this is doing is this is forcing the responsibility for doing that escaping onto the JDBC driver, right? So I can put apostrophe or 1 equals 1 dash dash, whatever I want here, and the JDBC driver is going to say, cool, I'm going to take this, I'm going to provide the proper escaping sequence, and then I'm going to run that SQL query. So I'm going to make sure that this gets treated as data to be used in that query conditional, not as potential code where I'm going to be changing the structure of the conditional or anything like that. Does anybody have any questions about that? Yes?
So that Colombian, what if you have 5 different parameters that you want there to be the name of to go back? So how do you set that?
So in this case, we've got, the SQL query has 2 parameters, right? So we're updating the coffees table, set sales equals something, or this equals something, right? So we can set So we're setting the first one and the second. If we had a longer query that said coffee name like this, or this, or this, or this, then you would just, those would have question marks in the SQL query, and we would just say, set number 1, set number 2, set number 3, 4, 5. Any other questions about that? Yes?
Yeah, I'm not a SQL person, but I'm just curious. It sounds that it apparently is still common.
Yeah. The question is we still find SQL injection vulnerabilities in applications, which is good for my one. Car payments and things like that. Thank you. Don't think I don't appreciate it. And I think it comes down to we've seen less over time, and it's good because people with like frameworks have stepped in and said, hey, we're going to have this object relational mapper where you're not going to have as close of access. So like inserting new records and things like that gets a lot harder. Certainly this is something that a lot of organizations have said that we're going to do it this way rather than letting people write their own SQL. But it still happens. And I think it comes down to it's just so convenient. And you say you're not a SQL guy. I'm not a SQL guy either. I know just enough SQL to be exceptionally dangerous. And it's funny because our director of technology, he hates hiring an object relational mapping tool because he was a SQL guy. He calls it the lost generation, right? Like nobody knows how to write SQL anymore. Whatever. But that's just such a natural way. If you're a developer and you're trying to solve a problem, you're like, okay, select what do I need? I need this, I need this, I need this from this thing right here where this condition is met. How do I know the condition is met? Cool. This is the data that got passed in for me, so I'm going to take that and drop it right in. Very natural way to write code. But so open you to those types of vulnerabilities. Yes.
They still teach that. They still teach that for full stack programs. They still teach that selective approach. And coming from a security background, when somebody teaches me that, and I say, well, wait a minute, what about security? And they typically say, you go to your company and they teach you security. That's what I often do.
We are also thankful for that. That's a great video. It's a joke that I don't know if you've seen those like fake O'Reilly covers. There's one that's cutting and pasting from Stack Overflow. It's how like I had an intern. I had an intern this summer working on some things for me. And what I taught him was like first of all the Google stuff and the cut and paste stuff from Stack Overflow. And I think he doesn't need to go to college anymore. But I've seen jokes that like if we go through Stack Overflow and find all their code examples and clean up the obvious security problems, like that may have like a disproportionate, like a force multiplying effect on the security of the world. Because again, and I've talked to folks that are running some of the coding boot camps and things like that, and they're like, yeah, we do data security. I'm like, no, like are your examples like you have example code like this that people are going to cut and paste or expect that to make things done? It's challenging. Even in a full university program, security is important, but it takes, it's got to slot in there along with things like databases, distributed systems, networking, all these other topics. And so in a lot of cases, it just gets pushed off to the end, and it's an aftermarket education, and folks like you guys have to come to this here today, which is great. We're happy everybody's here. But that's a challenge. Natural way to write code, a lot of bad example code out there, and I think the education system, the various feeders of the education system that are vocationally like building new programmers aren't doing a great job of instilling security from the outset. Any other questions about this right here? You're great. Okay, so again, what we're doing is we're forcing the responsibility to escape. So I can put all the control characters I want in here, and it's the responsibility of the driver to say, well, here's the single quote, cool, I need to turn that into two quotes. Or here's a backslash, I need to turn that into a backslash and something else. Callable statement, same thing. Saying, hey, I'm going to call a stored procedure. Here's the stored procedure I'm going to call, and it has two parameters that are going to be passed in, and it's the responsibility of the stored procedure to say, okay, here's number one, here's number two. You can screw this up, right? So for the real overachievers, if you still want to screw this up, Like, we could say, prepare a statement, update coffee set sales equal to question mark, where coffee name like, and then append a user input to that, right? So I can prepare a statement that has like built-in user input, right? So the point here is, whenever I have untrusted input, that they're being passed in as these parameters. And the point here is that however this show suppliers works, that it doesn't say, I'm going to take parameter number 2, append to a string, and send that to an exec, right? So these are, you can still mess things up in environments like this, but what this is allowing you to do is to say, this is the code we're going to run, and this is the data that is going to be provided to that code. And there's a separation between the two. Because when you don't control, when you just append untrusted input with static strings, you lose the barrier between what is code to be executed and what data is to be operated on. Any questions about that? Yes?
What if I send the previous statement,
There?
coffee name, like if I send a percentage?
So if the percentage was coded in there, that is good.
No.
But you're saying like percentage that?
Instead of Colombian.
I would have to, the Colombian? That is a good question. I would have to check and see the behavior of that. That may be something where you would want to validate that input. That's a good question. That may be databases. Yeah. That is a great question. That is something where your input validation can say, like, hey, this has to be, I want this to be the name of something, which means it's going to be, it's going to be upper, lower, but it's going to be alphabetic or alphanumeric text. Excellent point. Any other queries or questions?
Yeah, we do have a question. Today, what percentage of the code out there you feel has this vulnerability? And in 10 years prior to this, what percentage?
I don't have a great answer for that, but a way to get an idea of that, there's two really good reports that come up periodically. One published by the Veracode folks, their Data Software Security Report, and one published by the White Hat Security folks. I forget what it's called, it's a similar document. And I think I think that at least the latest Veracode one shows some trending over time of the prevalence of different vulnerabilities. I haven't had a chance to read their latest report, but I saw something on Twitter the other day. But that would be a good place to get an idea of the prevalence of those vulnerabilities and how they change over time. Yeah, so for SQL injection, I would say it's lower. If you look at things like cross-site scripting, that's still pretty common in a lot of applications in some way, shape, or form.
And why do you feel that? Laziness or lack of education? Or I mean, I wrote code 35 years ago. This is 101 stuff.
Yes. I think it's in there. Again, we talked a little bit about. I don't. From an education standpoint, I don't know that that's emphasized in a lot of the ways that people, whether it's through a 4-year university program, through a coding boot camp, through self-taught. I don't think that there's a lot of that education, and I think that the way that a lot of work gets done, which is cut and pasting stuff from online tutorials and things like that, that leads to a situation where a lot of this stuff can creep in. And applications that are developed by multiple people, unless you've got good peer review, code review, and standards for how you do this stuff, all it takes is one developer to do something goofy, and everybody else can be perfect all the time, but one thing can be wrong, and then you've got that kind of exposure. Any other questions? Good. So another thing, you want to control error messages. We talked about this a little bit. This is going to be really kind of specific to your platform, but you want to replace those verbose error messages. In a Java environment, web.xml, you control that with in your web.xml with those tags. And again, if you're .NET or Python or whatever you're using, basically, you want to turn off those verbose error messages. Those are intended for developers not to be exposed out to the world. So to recap, injection flaws occur when unfiltered user inputs get combined with static text and they get passed off to some sort of interpreter. It can happen with SQL, with LDAP, XPath, operating system commands. Any situation where you're taking an input and passing it off to another interpreter. To guard against this, you need to positively validate inputs. That's good from a hygiene standpoint. You also must escape user-supplied data before sending it to an interpreter, and preferably using, again, like a facility of the database or the operator or of your platform to basically say, hey, here's an input that I want to be treated as data. It's your responsibility to handle all of that encoding. You want to restrict attackers' access to error debug information and limit the permissions of the accounts. And again, the thing that actually fixes this is the escaping user-supplied data. Everything else is certainly good and important, but it's important to understand that you can't like ban SQL control characters in SQL queries because, for example, I knew a buddy of mine in high school named Brendan O'Malley. He's got an inconvenient SQL control character in his name. Right? You can't say, well, hey, no Irish are allowed to use this web application. Right? That's probably unacceptable in most of y'all's work environments. Hopefully that is the case. And so, so you have to be able to deal with those control characters, and the way that you deal with them is making sure that they are properly escaped per the context that has been provided. There's some references, and Josh said that some slides are online. Let's take a 5-minute break now. If folks want to get a bio break, grab a coffee or whatever, and come back at 10:45, so 6 minutes.